difficult to, I can do it from here, I suppose. Because I haven't got a machine with limit switches on it, I have one switch here, which is connected to a number of switches connected to the card, like limit switches. This is a limit switch. This is a home switch. And here's an e-stop switch. See the red knob? That's an e-stop switch. And here's another switch, which is a rotational switch for the MPG to select between no axis or the x-axis or the z-axis. I'll show you in a minute how that works. So if I, what I do with my mouse, if I go here to reference, see if it works here.
It's still going.
But difficult with this.
Like net op papier.
Yeah. Now I'm in front of the projector. My screen is not working, unfortunately. So to start, see the one motor is running. If I press it once, it stops and goes slowly back, and then as a normal reference switch works, goes forward, hits, comes back a little bit and goes slowly forward until it hits again, and the second time it registers. And now you see it's 0. X, the diameter is 0. That changed from a value to 0. So I can do the same with the other one. It's a bit clumsy. Do it this way, but anyway. Same story there. So now they're both referenced. It won't allow you, normally, unless you jump over it, it won't allow you to do anything else until you've referenced. And well, that's basically the axis. You can jog on the like here on the keyboard. You see the motors running. Or you can do it with the MPG, which is not connected. No, I didn't connect it. I forgot to connect it here. I was talking to somebody and I didn't do it. So I'll do that later. But you can also turn it with this, the MPG. Have to plug that into the board, then you can do it with this. The big advantage is not so much the screen, although it's a very professional layout. You see, let's start the spindle and see what happens. So to type in to start the spindle, you have to type in a value here, say 1000 RPM, and then you start it here. And because I'm not in the right mode, it won't start. And because I didn't plug my spindle in, it also won't run. Stop it, look at the reverse it. Stop it, forward. You notice on the spindle motor I've got an encoder. That little belt, timing belt there, with the little black box at the top is an encoder. And that actually counts the number of revolutions accurately. It actually subdivisions of, I think it's 100 steps per revolution that it gives. So that is used as feedback to Linux CNC to do what is called synchronized moving. If you cut a thread and you set the spindle at 500 or you set it at 200 and you want to cut a pitch of say 1 millimeter, then the z-axis has to follow for one revolution, it has to move 1 millimeter. And depending on the speed, that axis must move faster or slower. And that's done automatically in the background, and it uses the encoder feedback to synchronize that accurately. You can cut any thread, of course. Now it's CNC. You just type in 1.253 and it will cut you a pitch of 1.253. You don't have to, you're not using gears at all like on a normal way. Also for constant speed cutting, depending on the radius, the speed will increase, and I will show you in a minute. It's also why we use that. So that's basically the main difficult part, is to get that. It is a VFD there, the little black box behind is the VFD, and that has to be switched on and off, and it also has to be switched for forward and switched for reverse. So there are a couple of lines, you can have a look later. A couple of lines going to 2 relays, which switches it forward or backward. And then there's another line which gives a 0 to 10 volt signal. That 0 to 10 volt determines the speed of the motor. Most of the VFDs work on a 0 to 10 volt, kind of an analog signal. Some work on PWM, pulse width modulation, or other ways, but step in direction and so on. But what we normally use simply for a spindle is a 0 to 10 volt signal. So that's basically the hardware. Any questions on that? Anybody who hasn't seen it yet?
Proef daai die spindle mens is dit maar wat hulle gewoonlik doen om 'n eksterne encoder te hê.
Ja, spindles is gewoonlik op eenvoudige draaibanke is gewoonlik 3-fase motor. So ergens moet jy net van jou spindel af 'n pulley hê. Jy kan selfs 'n magneetje op 'n pulley sit en dan 'n sensortjie, 'n holsensortjie langs aan sit, maar jy moet 'n sein kry. Jy gaan 'n puls soveel en verkieslik meer as 1 puls per revolusie. Maar ek gee 100 pulse per revolusie en dan tel hy dit op en dan kan hy nou synkroniseer.
Maar hy ook 'n indeks nodig om te skroekat. Kyk, jy kan ons laat ons skroekat sonder 'n indeks. Jy moet jy encoder.
Ja, die indeks word opgestel. Die indeks word ook gebruik. Ja, die encoder het 'n indeks en die indekslyn word ook gebruik. Ja. Ekskuus, ek het vergeet om te sê. Jy het 'n A en 'n B sein, die 2 fases sein, en dan jy 'n indeks sein van die encoder af na die rekenaar.
En jy met 'n tool changer, want obviously met 'n tool changer moet jy nou 'n klomp custom goed.
Ja, ek het my draaibankie het 'n 8 tool changer op. En hy werk. Jy kan die tool jy kan 'n tabel insit en jy kan die tool kies en hy werk. Maar daarvoor moes ek nou 'n klompie goeders oordra van Linux CNC af na, ek sal maar sê, Tomac Linux CNC toe, want hulle ongelukkig haal hulle 'n klomp goed uit. Classic ladder, L-show, al sulke goed haal hulle uit, hulle sit dit nie in. Hulle vat basiese Linux en dan laai hulle 'n klompie goed net wat hulle nodig het van Linux CNC laai, en hulle laai nie die hele lot goed in. Maar jy kan dit oordra van enige ander 64-bit tipe installasie van Linux CNC, kan jy die tools, ek maar sê, wat in Linux CNC is, kan jy oordra so intoe. So ek gebruik Classic Ladder in my ander draaibank om die tool changing te doen.
As ek kyk na hierdie waar jy jou cutter in my geval nou het ek 'n gear holder waar jy 'n synchro motor op 'n milling machine so as spindel gesit met 'n synchro na 'n kaart wat Johan Smit oorlede Johan Smit gebou het in die masjien.
Ja.
En dan gaan dit na 'n headstock wat jy op die tafel sit en daar is jou cutting stock. So jy het 'n hok, 'n spindel en dan die gear wat jy nou wil sny. En dan sommer met die X en die Y's bring jy maar net die hok in en hy sny en hy gaan weer terug en daar is jou rak. Maar dis 'n module 1, so dit werk nou goed. Hy het 'n thumbwheel selector waar jy hoeveelheid tande wat jy wil hê, doen jy en oor eerste met die diameter en dan sien jy net sny die rak en dan sny die rak en 5 meter is die rak daar. Maar die probleem is as jy 'n 1.25 module het en jy het 'n ander diameter cutter, dan werk daai thumbwheel nie meer nie. So ek neem aan met hierdie dan is daar sulke prosesse waar jy verskillende size hops kan insit en verskillende diameters van feedstock kan insit en hy het 'n manier om dit klaar te bereken.
Ja, jy weet, die ding, Hy het hom nou so geprogrammeer dat hy net sekere modules kan hanteer. Nou as jy na CNC kant toe gaan, kan jy enige waarde intik, of dit 'n module is of nie, of 'n jy weet 'n Britse eenheid of 'n dun eenheid of 'n metriese eenheid. Jy kan hom indeks op enige hoeveelheid grade, sal ek maar sê.
Al die dinkwerk is in die PC.
Ja, ja. Jy moet hom nou maar net gaan uitwerk. Jy het soveel tande en jy wil jou intervalle is soveel grade. En dan kan jy vir hom sê loop 5.5 grade of 5.7 grade of wat ook al. Dan sal hy indeks en dan sal hy die volgende tand sny. Ek het in een van my frismasjiene het ek so wat ek net vir radsny gebruik, wat ek so indekse op het en jy moet maar net dit programmeer in jou, maar jy is nie beperk dan tot fisiese intervalle en so, wat hy nou opgesluit het voor die tyd. Nee, jy kan dit kan jy oplos, ja. The big push after, this is a very nice layout and it's really done it quite professional, I would say. It's also designed for a touch screen. In other words, this is actually a touch screen, but I didn't bring my touch cable along. You need to add another cable. I can't demonstrate. It's actually not working at the moment, the screen, for some reason. So that's the other thing, advantage. It's a touch screen. The buttons are bigger than the normal Linux CNC interfaces. And the other thing is, it's got a lot of background stuff here, which is very nicely laid out. To update, you can just click on the USB, you can eject and so on. It's got a lot of buttons on the screen, which are touchable, and you've got directory for your files, and you can rename, delete, you can edit and so on, all from the screen. You can have a Gcode preview. I'll show it in a minute. There's settings where you can set things like, manual tool change is what I'm using at the moment. You can go to a turret, you can go to game tooling. There's a number of settings that you can do here. Then you get to your tool setting, which is very nice. It's a graphical touch off and diameter setting. You set the number of tools. You can set the orientation of the tool here by just clicking on it. You don't have to type in any numbers or so. So that it's really nicely designed. You can have a rear post tool and you can have a front post tool. There's an offset table for all your tools with the X and Z offset, the wear offset. It's also got a wear offset in it, and then the nose radius, and then your orientation of the tip. So that's very professional. But the big thing about it, I think, is the conversational programming, where you've got the option to just input a few parameters here, click all these white boxes, type in what you want, and then it will generate the Gcode to do that operation for you. So you don't really need, if you go through all of these, we'll go through it slowly, you don't very rarely need to go to a CAM program to generate a complicated thing. You can even do complicated things with this. But the standard stuff, like here for instance, is an OD turn, a straight turn where you can set your increment of turning. You can set a radius here. There's a radius, you can infinite radius. You can set the diameter, and you can set the finish depth of cut, the roughing depth of cut. Everything required, and if you click on it, it takes these basic things in. You post it to a file, you can add it to another file. In other words, you can have a number of operations stacked after each other and combined in one Gcode file. It writes the Gcode file for you, stores it, and then it runs it when you start it. So this is called conversational programming.
Does that actually then replace the need for a CAM module?
To a large extent.
Except for
I won't say completely,
but
for a lot, as you will see here now, there's a lot you can do with it. There's a lot you can do with it.
Can you do a similar thing for milling as well as just...
They have, for milling, I haven't got anything now, we can do that another evening, but for milling exactly the same. They've got for pockets, they've got for tapping and drilling, and for surfacing, and for outside profile cutting, inside profile cutting. They've got removing material. All that stuff is there. I would say not 100, so close to 100% with milling, but with lathe, it's basically close to 100%. You don't need a cam, as you will see. So there's OD turn, there's ID turn, inside turning. All the parameters that you would normally use, you can specify here, and it will generate the Gcode and store it into a file. Then there's a profile, the most powerful thing, and that only came now recently with the latest version. It was not in the original version. This is what SA-CNC does not have. SA-CNC does not have this facility for a lathe at the moment. There are guys who've played with it, but they've not officially put anything into SA-CNC comparable to this. And this is even more powerful than what you will find, strangely enough, on a professional control like a Siemens control, or a Haas, or a Fanuc. They have a control, they have a profile cutting which allows you to cut variable profiles, but you need 2 Gcode commands to do it. This guy has combined it into one. It's only one command. I'll show you. So here you can define a profile, and you can build a profile with a number of points. I'll show you in a minute in the manual how that works. But this is very powerful. This is
like G71.
Pardon?
Is it like G71 then?
G71, and there's a special, I think, a G72 that it combines that in a professional.
It's
basically what it is.
Similar to that.
Yeah, basically what it is. Then there's a face. And notice that you have parameters that you set here. I'll come back to that. Tool clearance, finishing depth of cut, finish depth of cut, and so on. It's facing. Chamfer, either a radius or an angle that you can set any kind of chamfer you can do with it. There's a groove and part operation. There's a drill and tap operation, to drill and tap, and there's a thread operation, which is also very nice, where you can just, if you've loaded all the software, you can just pick a thread and to load all the diameters, all the information for you, and you just have to specify things like depth of cut, the number of passes, and your dimensions, how long do you want the thread, and diameter and things like that, and your spindle RPM and so on.
I see that one is particularly metric. Can you switch that over to imperial if you want?
Anything that, they've got imperial tables and they've got metric tables, so they've got standard stuff loaded already there.
Change G21 to G20. That's it.
So this is basically the reason why people want to go for this. Let's go and show an example. I'm going to go back and show you all of these just in the manual. There's a very powerful manual coming with this, which I've got on the machine. I'll show you in a minute. But I just want to quickly show load a file, just to show you something that this is my test threading. Load the Gcode. There it is, and if I start it now, waits for the tool. You will see the spindle is running now, and the feed is adjusted to the spindle speed automatically. Second cut. And you can see the speed varies a little bit at the bottom. That's how it adjusts to the speed. And there's the Gcode command there. G76, the standard threading command for you, the guys who knows Gcode. Let's have a look at the program here. It has a nice layout at the front, all comments just to tell you how it generated all of this. That's before it gets to the Gcode. Then it gets to the Gcode, which is standard. Diameter mode, XZ plane, absolute distance mode, turn cut compensation of units in millimeter, and work offset, then a tool command to change the tool number 4, the RPM command, coolant on, spindle on, I haven't got any coolant tonight, spindle on, forward, then it goes to the beginning, and then it runs this command here, G76, which is the threading command. One command.
I see here on top there, G30Z #5422. What is that? #5422.
That's a parameter where you know the tool position, the tool change position is stored. I think that's what it means. Hash is a parameter. If it's a comment, if it's in brackets, if it's a hash in front, it's a parameter.
Yeah.
So it's got 2 parameters, one there and one there. You know, the same basically part 2. You can set it here. There's a set G30 here and a go to 30. You can move the tool to a specific position and click on that button, and then it stores that address.
G30.1.
Yeah.
Is that hash referring to G30.1 then?
Yeah, I think it's basically the same. Let me just see if I can find another code here.
I know House also uses a lot of these hashes.
I've got, for instance, let's look at this facing, because that's interesting. That's a facing which will show you the constant cutting speed. As it goes deeper, closer to the 0 axis, the speed goes up, and as it comes out, the speed slows down. So let's see how that works. So it wants a tool change. Slowly the last cut. That's it. So that's the synchronized motion that I talked about. That's why you need an encoder so that it can change the speed. Advantage to have this constant speed, 100 meters per minute. Doesn't matter what the radius is, it will cut 100 meters per minute. Your actual cutting speed on the metal is 100 meters per minute, which gives you a much nicer finish as you go towards the center. Whereas normally it slows down. If you're on constant speed, you get worse conditions as you get closer to the 0, smaller diameter. What else did I want to say? It's got all the other standard stuff to control step increments and things like that. It's very much the same. It's just the layout is different to what we used to.
I just want to ask the threading algorithm. How fast can you thread with this?
How fast can you
thread with it?
That depends on your machine. You know, it checks if there's spindles, there's a near function. It checks if it has reached the commanded speed from your spindle. If your spindle is running at the speed that it should run. If it doesn't reach that, it won't start. So that depends on the hardware that you've got, whether your motor can spin up and reach that speed or not.
And this specific setup here.
No, this is not a physical, it's not a real machine, this is just a demo system, so I haven't checked what the limits are.
What I found is, I use synchronization somewhere, and it starts to hunt.
Yeah. I think, you cannot control a spindle motor as quickly as you can do a servo motor. So there is a limitation, and what you can do in Linux CNC is actually set up a PID loop, so that there's always control. The PID loop keeps the command and of the spindle speed and the actual measured spindle speed within a certain tolerance. And it won't.
With my specific setup, which is not closed loop, step.
Yeah.
and I can do 1mm threads,
Yes.
but the moment I go 1,25,
Yeah.
it starts to
Yeah.
finer threads I can do.
Yeah.
But then what RPM?
Yeah, my RPM, my minimum RPM is too high as well because it's fixed.
Now, if you look at industrial machines, the spindles are huge.
Yeah.
They are huge, and they are massive to be able to, they speed up that big motor up to 6,000 RPM just like that, and they bring it down, and it almost breaks to a standstill in a second or half a second. So you need a big motor, spindle motor, and a big drive.
Let's say you must use the index as well.
Because
I've read there somewhere in the manual, I've only got two light detectors, with the slot.
A and B, so they
A and B.
A and B.
But there's something in the manual for the index, you use A.
You can use A also for an index.
Yeah. That's what I mean.
They simulate.
That's a problem as well.
Simulate that.
Yeah, see, this screw cutting only relies on the index, so it is as accurate as the spindle runs constant speed. So if the spindle doesn't maintain that speed, it runs every index. So if the spindle runs a lot, and then it only from the next index C it's behind or forward. So it smooth things out. But if the spindle is not constant, the threading goes not accurate. Yeah, so
It's beautiful threads about
yeah, but if you run a VSD with a constant voltage, it tends to run reasonably if you cut thread.
I think Leon's right. I think you need a very good inverter. If you look at the inverters that Van Look generates and Siemens generate, they're huge things. They're so complicated, and it's because they can keep that speed so constant. They can keep it within 1% or 0.5%. They can keep it constant.
My spindle is just a normal single phase induction. That's that.
Yeah, but if it runs constant speed, it cuts reasonably good thread. It doesn't hunt the spindle because you hit the spindle.
But stepper motor starts to hunt.
Oh, but see, that's probably because it struggles to reach the simulation. The Z-axis must also be able to follow quick enough. But because the problem with threading is if you start further away and your acceleration is low, it doesn't reach. So that's why it has that running. So my problem is if I cut 400, 600, 800 RPM, then when you withdraw it, you hear that servo performs. And because it comes there at this speed and then it stops and retracts. See, and that thing it goes, and that's the problem. So you have a massive acceleration.
It has to stop almost immediately and then pull out.
See, I don't think that
You can pull out at an angle.
Yeah, but I tried that settings. To me, it doesn't work. There's a bug or something because it runs, it accelerates. And now here where you want to pull it out, they have settings, but I don't know if I figured it out wrong. But you come fast. Because if you run 800 RPM 1mm thread, you run at 800 millimeters per minute, which is fast. It's like this. And now you withdraw that too fast. And that servo stops. If you look at the drive's current, that servo stops fast, and then this one pulls it out fast.
Now, I've got a similar problem on my small lathe. It's an old DC motor, 400 watt motor. I'm going to replace it probably with this motor or something similar. Because I think that motor is just too small, and the axis motor also you can't follow. If you go to higher kind of pitches and so on. I saw yesterday a new viler that just come from Germany, and it can cut. It's about I would say 3 kilowatt system. Basically a lathe with 140 chuck, 140 millimeter chuck, to give you an idea of the size of it. And they cut at 2 TPI pitch, up to 8 millimeter pitch on that. And it's all automatic. It's not a CNC machine, but it's now electronic gearbox, and it's got built in, because it's got scales. You can tell it start here and stop here, start here, stop here. So you can cut a thread, it stops, and you just change the lever, go forward and go back, and you do the feeding. but it's got like a 7 kilowatt motor in it with a huge inverter, and I think that makes the difference. Let me just show you the manual.
But that might be one thing we must explore, is the thread cutting and lining CNC, because they say you're supposed to withdraw in half a thread, and I always cut it looks like it stops. It's a revolution and then withdraws. I can't believe to withdraw.
I've also got I've got the induction motor as well, and I can't go slow enough. So I have to tread a little bit faster than I think is advisable. And the tread is perfect except on the end, when I pull out.
Yeah.
Then the thread goes a bit funny. And no setting I've tried can avoid it.
Yeah, it looks like it rapids out. It doesn't feed out. So now, if now it determines your rapid acceleration. So sometimes if you cut deep threads, there where you start rapiding out, the rapid, the subsequent cuts is a bit bigger there. Instead of following, you actually want to pull out better.
I think it could also be the Linux code as well. It's not perfect.
I don't know. They say you're supposed to be able to pull out over 3 threads. So then you cut more taper like.
I've actually got my doubts about it, to be honest with you.
Yeah,
that there's room for improvement for the coding.
Get an expert that tries it and figure it out.
Yeah, I haven't got enough experience with that. I've used it, but I haven't got enough experience to have seen that. On my manual lathe, I normally cut a groove at the end of the thread.
Yeah, but see, your CNC you typically don't want to. You want to pull it out.
You don't want a groove.
You want to pull it out over the revolution.
Yeah, but now I can see, you have to pull it out so fast in order to have that last thread still on the right dimension. I can see it's a problem.
Yeah, but see, you pull it out like over one revolution. So, so you always pull out, and then the last thread just gets swallowed.
Yeah.
You get CNCs, if you look at threads, that beautifully cuts it like that.
Yeah.
But I don't know if one reads the manual wrong in terms of that setting, but it looks like that setting doesn't work.
Okay, I'll have a look at it.
I mean, I had a word with DK as well, and he also thinks it's Linux-based problem more than anything else.
Is it possible to hold a mechanical ejector, and when you get there, it runs up a can, kicks it out?
Okay, just to show you
like that.
Just to show you a little bit about how it's organized in Pathpilot. You've got, basically I've got all the old versions there. You can see version 2.1.3, 2.1.4, 2.2.4. I'm not running that at the moment. That they've changed so many things that it's again a mission, and that I can warn you. You go down this road, it looks to me like if you want to be a non-Tomac user like I am, then every year or 2 years you'll have to spend a week to get it back to work again. So what I've shown you here is 2.1.3. Yeah, this particular version. It's got there's just lathe files. I've got some club files here, pictures and so on. The rest are all the standard files. If we go to a particular, the current version is there's a link to this one, so if you click on that, you get the current files that are used for what I'm going to have here. The binary files, the configs. You'll see here there's the Mcode. I'm also running it on my other machine. It's running with a 5i25 card, whereas this one is running with a 7i76 card. I've got a mill with a 5i25 card. There's a Tomac lathe and a Tomac mold. These are the standard things you get with the software. And then some common directory. Then it's got material data. It's got the bit files for your Mesa card. And this is what Marius was going to tell us about tonight, but unfortunately he couldn't come. So we'll deal with that later on in the next meeting. Or so. Then there's the Python code. This is here's basically the source code of the whole thing. All the Python programs for lathe and for milling machine and so on. So if you want to, if you're a Python buffer, you can go into study them and actually change them if you want to, or develop your own versions from that. So it's open source, it's not closed. It's all open source. They keep it open source. The runtime library, these are all the components that are used, and you will find that a lot of the components in Linux CNC are not in here. They only put in there what they use. You may need, if you want to do a tool changer or so, you need some others, then you just have to copy it from another computer and dump it on this in this library.
How do you know which version of Linux CNC they use? 2.8?
They use that's the other disadvantage. They used an old version of 2.8 before they actually changed to the axis joints division, where they changed the whole definition of axes and joints. That's before that. So this is still the old INI construction, INI file construction, old HEL file, not the latest one. So that at some stage they're going to convert obviously to the latest one, and that'll be a major rehaul again, to adjust to that. Script, subroutines, TCL, all the basic things are there. The startup procedure that they provide is, let's go back here, is in operator, and that's a bit difficult to figure out how it works. Normally, when you start it up, it runs a script called operator.login. Where is it now? Here it is somewhere. And that runs another script, which is this JSON file. And in the JSON file is customized for your particular machine. Like, for instance, if we look at my, where's my JSON file? Here's my, the one that we're using here. So it's a bit funny that it uses two INI files. It uses a base file. It's always called your name base INI, and then it uses a specific file, and from those two it generates a normal INI file, which is actually the one that's loaded when it runs. So it's got a basic file that gives you the base configuration, and then you can modify it by putting something in a specific file, and it overrides whatever it kills. It deletes this file when you run it, if you make any changes, and then it will create a new INI file. So it gets a bit, takes a bit of time to get used to that. Then here you can define whether you're working through Ethernet or you're working through the PCI card, the 5x25 for instance, and some other commands. So what I've done is to make it simpler, and I've just written a script, like for instance this one here, or where's the one that I use, that one. We open it with the editor. So all that does is it copies that JSON file into the standard one. Name is always what Pathpilot loads, is this one here, pathpilot.json. So it copies my own file into that one, and then it starts Pathpilot with operator._login. So that's a little bit of a trick customization just to get around, because otherwise when you boot up the machine it comes up with Pathpilot and you're in Pathpilot, and when you develop and you want to modify and so on, that's not convenient. And you can't sort of get behind it to see what's behind it. So I've changed it so that, as you've seen now, I can work in Linux, and I can start Pathpilot, I can kill it, and I'm still in Linux, and I've got access to everything. I've written a document about that. I don't know whether you've seen it. Let's go back here. I think it's in here. It's this install Pathpilot document. It should be on the website. Tells you how to customize and do that, all that changes that I've made to it. This is a bit small now, you can't see. How do I increase it? But it's there. Something else I've got here is just lathe code and Gcode examples. Then this diagram, wiring diagram, should be on the website. These. That's basically the Mesa card showing all the different connections that you can make, and that's what I follow to do all this connection. So it's very easy to follow for digital. This is for digital input, for digital output. That is like switches.
Is that standard, or can you just do the ini file according to your stuff? Do you have to wire this, right? This inputs? Or can you just map them in the ini file, like in the HAL file, like you want?
No, I'll show you now. It's a standard ini file, standard HAL file, because it's read by Linux-CNC. That part, it's only the GUI that's changed. It's not Linux-CNC itself. So it's standard. I'm just showing the. Sorry, I've digressed now, but this is now just the wiring of this Mesa card, which is in this document. We discussed it last time.
Yeah, so it doesn't have to be like that. You just do the HAL according to your.
But this is just an example, but this is just to show you how to do the Mesa card wiring. This is the physical wiring. And it also shows the pin numbers here. You know, the output, the actual whole name of the pin that you will use in your HAL file. So that's output. There's MPGs. I've connected the one MPG here on the side using these three inputs here. Steppers, how to connect the steppers. You can go up to 5 steppers here. And then the spindle, exactly like this, the encoder. There you can see the A and the B and the index at the top, and these are the power signals. And here's the VFD signals. VFDs are different. You may have a problem just to follow this, because not every VFD is the same as the other one. The way they control the forward and the backward and how they switch it on and off, that may be different. They all have a 0 to 10 volt kind of input, but the way to control the forward and the reverse and so on may be different.
Some has a forward relay.
So mine is not exactly like that one on the screen at the moment.
So what do you, because some of them they call this for sourcing, and you know, some VSDs you must short the contact, other you must give a voltage.
Yeah, that's everyone is different.
Yeah, so I have to put relays in so that you switch the relay and the relay.
Yeah, the relays. Those are relays.
Yeah,
just shows you how to connect the relays.
But for the forward and reverse of the spindle.
Mine is also, you'll see a relay on the top. There are 2 relays there. I did the same. Yeah, so for those who haven't seen this, we discussed this last month, so I'm not going to take more time, but it's on the website. So if you get the card like this, have a look at this document. It's quite complete, and it shows a lot more than what is normally in the manual. You know, it's easier to use this than what's in the manual. It comes with a card.
Prof, that install Pathpilot file, I don't have that. Prof must send it to me, so I'll put it up.
Yeah, I'll send it to you. I'll send it to you. I'll put all these files that I've put here as club files. I'll put
Is
into
there any way to download the Pathpilot, or do you have to buy it from them?
You know, we've spread copies around here. I think one guy brought the stick in, and we've just copied it to a number of people. So you can get a copy from me or from Marius or the guys down in Hermanus and so on. They've got copies of that.
Okay.
You can buy it, I think it's $10 or something like that. You can even get the source codes for $30 if you want the source code of the whole Linux stuff. You know. Linux-CNC stuff included, but that you can also get from Linux. I wanted to show something else. What did I got here? Okay, these are just this. I've got some pictures here for people that are not here tonight, just showing basic layout, and then I've also showed the wiring. The pictures are not very good, but just showing this network of wiring. So here, just to explain to you now, but you can have a look later. Here we've got the card. We've got a little 5-volt power supply here, very small power supply. It powers the board, the logic of the port. That light goes on if this power is on. There's a 24-volt supply coming in here, which works on this side of the card. That's all the I/O, the input-output part of the card. There's a 24-volt supply. It can be anything up to, I think, 32 volts from, I think, 6 volts to 32 volts or so. But typically we use 24 volts. Then here you've got your 5 steppers. I've connected just two. There's the blue and the white connections here. That is the one stepper and the other stepper drive. That's basically step and direction commands and an enable command. And they are so-called differential, so you've got two wires per signal. There's a plus and a minus to make it more robust. Then we've got all these switches. There's the limit switch, and there's a homing switch, and there's the switch to change the MPG from X to Z, and here's the emergency switch. They are all connected here. This part of the board is for input. These two lines here up to there is for input, and those two connectors there, 16 of them are for outputs. So relays and anything that you want to control outside, like switching the spindle on and off and things like that, go on this side. And inputs from the switches and so on, they all go onto these. Here's your power, 24 volt in, and then connected. Because there's so many little connections here, I just put this thing here to have the ground connection more spread over a number of terminals. Then the encoder of the spindle goes here in the middle, and the MPG goes here, and the other input of the spindle is here. It's basically spread from there. The output is here and the input is here, or the output is here and the input is there. So that's basically the layout. This is just a motor with the two pulleys and the belt, and the encoder sits here. There's a cable with the A, B, and Z signals, the index signal in there, and then the two stepper motors and the two stepper drivers here. They've got, as you will see, these steppers are so-called closed loop steppers. They've got encoders on the end of them, and they've got feedback. So if you lose a step, it'll immediately stop and give you a signal, an error signal. And that's the modern way of doing it. I wouldn't even think of putting any non-closed loop stepper on a machine nowadays, because these are so cheap now. They've replaced, and everybody is selling them now. They've replaced the normal old open loop steppers. And they're three phase as well. They're more silent, they run faster, they're smoother, they don't have resonance problems and things like that we used to have with the old Gcode drives and the steppers. Just the connectors, the control, step and direction, and then the encoder connection, and then the power connection there. This is just the MPG, and there's the VFD. It actually shows the frequency there on the dial. You can set it to also other outputs. There's the control for switching on and off, and then the other line is just the 0 to 10 volt speed line. And here are the two relays that I talked about. They're sitting here down. Those blue things are the two relays for switching forward or switching reverse. This particular VFD works like that. With a typical MPG, you'll have the big 100 step per revolution wheel, and then you typically have a switch to set which axis, and then you also have a switch to set the increment for one step. It'll move 1 millimeter or 0.1 millimeter or 0.01 millimeter or 1 micron for each step that you move that wheel, that you can set with the other switch. That's typically what you will find. I've got some other switches here that I put in, but that's now not standard. I'm using two 24 volt supplies at the moment, one for the motors and one for the relays and outputs. I could have done it with one, but it's just easier to plug in two. And then the 5 volt supply. There's the other one. And that's basically all the hardware. This is not much better. There's a better picture of the actual Mesa card. You can add other cards to it through these two. It's a very powerful card, very expandable. You can connect two next to each other and so on. All the communication to the computer is through this plug-in connector there of the Ethernet cable, and this is just a 5 volt power supply. And then your 5 steppers, your spindle, and your power, and then the MPG spindle control here, and then these are basically IOs, inputs and outputs, digital inputs, what they call digital inputs and outputs. The card costs about $200, I believe. I haven't bought one for a long time, but I think they're about $200. I don't know how much rand that is. It depends on the day. Yeah.
But that card, there's a few chips on it and that's all that.
There's the FPGA, and Marius is going to speak to us about how to program this FPGA next time when we have. You were supposed to be here tonight, but he couldn't make it. So you have to load what's called a bit file into it, which makes this thing intelligent. It's a Johan, wat noem mense die FPGA? Wat is die volle naam?
Field programmable.
Yeah. So you need quite a big, elaborate piece of software to program that thing, and it writes a bit file out, and then you load it into this automatically. That's one thing that Pathpilot does. It checks what bit file you've got, and if you haven't got the right bit file, it will load it automatically onto it. And people are surprised when they stick Pathpilot in, when they stick the card in, it loads a different bit file onto it than was there, and then they're surprised. But
so if I was always under, maybe I'm mistaken, but I think the FPGA was something that you programmed in the field once, and that was all. You couldn't change it again.
No, the latest you can.
You can do it 10,000 times now.
So I'm maybe thinking.
It's not. There's no practical
In the
limit.
old days when you burn that EEPROM and then you put the sticker on it.
Maybe I'm thinking old.
No, these modern things are so powerful.
It's supposed to be a logic, programmable logic. These days, there's so much stuff in there.
Okay, let's just have a look at the manual. User documents. Here are the manuals for different machines. There's a MX, I think it's a lathe. There's the release notes. There's the slant bed lathe. There's the milling machine 1100, and the big one and the small one. So let's just have a look at this manual. It's quite an elaborate manual. It starts with setup, electrical requirements, receiving, uncrating, initial inspection, and so on, basic installation procedure, and so on. Tells you how to put the whole thing together. Then operation, power off, power down, work holding, tooling, introduction to Pathpilot. This is where you learn how to use Pathpilot. Setting work offsets, set the length units, and so on. By the way, some disadvantage of Pathpilot is its internal setup is in inches, is imperial. Don't even think of trying to make it metric. You're going to come to a closed door somewhere. So you have to set it up in inches, inch per second, and everything must be in imperial units. And then when you start it up, you tell it with the G21 command as the default command. It changes all the user interface works in metric if you want to work in metric. But you can't make the setup in metric like we normally do with Linux CNC.
America first.
Yeah, they've done it for the American market, and that's it. They don't. I tried to do it, and I started changing, and then I saw some funny numbers coming out because it converts all the time, inside. So it's better to set it up, leave it in inches, convert your normal metric stuff to inches, and then set it up. So this is all on Pathpilot, and then managing files, offset tabs, and so on, thread tab. So let's just have a look here. For instance, conversational screens is what's now new. It's got quite a nice. What is this? No, we can't. Yeah, it's a bit. It explains all the various data on the screen. This is the OD turn process. You've seen that it explains it here, shows you, explains all the inputs. Then the ID turn explains that these are fairly easy to understand. The one that you have to really read the document to get behind it is the profile one, which I want to go to. Here it is. So here's an example which explains, for instance, with these 5 steps here, the table here, you define this profile. So you've got a stock diameter of 1 inch. This is now all imperial in the examples, unfortunately it's all imperial. Stock diameter is 1 inch. The tool clearance is 0.05 inches. That's that clearance there. The stock Z, he sets it as Z to start with Z at 0. And the tool clearance is 0.5 inches. Then he defines the first point to move to. It's 0.7, X is 0.7, and this is all diameter. And this is you normally work from 0 negatively. So he starts at 0.02, which is there, and he goes to that point. So it's there. The next one, it just goes to 0. It doesn't, if you have a blank number, then it means that value is the same as that one. That value there is the same as that one. Then he moves to 0.6, which is here. That point there, that's 0.6. And distance from there to there is minus 1 inch. Then he moves to 0.55, which is that point, and the depth is minus 1.05. And then it goes to 0. That means the Z there is the same as that one. So that is the profile, going there, and going down to 0 with those 5 commands. And it generates the G-code for you and loads it automatically, and you just click start. So that's a fairly simple one. Here's a more interesting one. To cut this profile. So you start here at 0.605 diameter. You set these stock diameter and all these things like before. It starts here at 0.2, goes to 0, moves from there to there. Then it goes to minus 0.5, which is here. So it will cut to there. And not in one cut, of course, it will do, depending on your roughing and finishing, which we'll come to in the middle, it'll do a number of cuts, but the final profile is what you're defining here, will be there. Then you can go down 0.575, minus 0.55 to that point. Then you move to minus 0.75 here. Then you do a curve. That is a curve. There's a radius involved here, or a radius of 0.05. So what you define here is the end point of the curve. You're already at that point, so you have to move to that point by using a curve, and the radius is 0.05. So it's fairly simple to build up a profile of curves and straight lines and so on by just defining the end of the next move every time. And if there's a radius, a positive radius is going the opposite way. Is going sort of clockwise, and a negative radius is going anti-clockwise. You can have a negative radius. Then you move to the next point, which is 1, and then you move out. So that's another example of a simple profile. Let's go and see if we can find another one. Now here's a more interesting one. With a table of 4 rows, you can define this profile. Okay, and you move in from there to there with this first command, 0.75 minus 0.4, that's that one. Then you define a radius. The end of the radius is here. It's 0.573 minus 0.82, and the radius is a 1/4 inch. So the radius sits somewhere here. It works automatically out where the radius is, and will do that radius for you. Then you move up the slope with a straight line, 0.82 and minus 0.95, and then you move up to 1. And it generates with one command, G71, a full, and I think I'll show the code, that whole profile. Whereas in a Haas or a Siemens or a Van Loop, you need 2 commands to do this. And normally to go to cut a groove, to reduce the diameter, you need what's called a second command to do that. So this guy's combined it all in one now.
Prof,
Yes?
you bring the shape of your tool tip into this.
Yeah, here you select tool geometry, you select it here and it actually shows the tool and it checks. It will check for interference. If you put a blunt tool in there, it draws a red line. It in fact knows that tool can't cut the slope.
Can't cut that radius.
Can't cut, that's why it's red. That's why it's red. So it does a wonderful, that's also very robust. It checks whether your tool can do the job. From the geometry, the radius of the tip and the two slopes of the tool must be defined, and it will check that for you on the whole
So it'll
profile.
tell you if it's going to
Yeah,
damage
it'll tell you.
it.
You can't do it. So that's very powerful. Then you've got your finishing, your roughing. That's actually how it will cut. You can see now the cuts, how it builds it up and goes over the hill, goes down and does these cutting. And then the finishing cut is the final cut, which you also have to set the depth of cut and so on. You cut the final profile. Here it explains that the angles. You've got to set the radius, and you've got to set the back angle and the front angle, and then it will check. And if it's isn't a yellow line, then you know there's a problem, and it won't cut. It can do a rear tool from the rear, coming up from the rear, or a tool from the front, with a positive X and a negative X, which is a bit, you have to get used to it because it's normal working for positive X is from the back forward. So it's their machine is designed with a rear tool post. It's actually a tool changer on the rear side, which is very nice. I've seen now machines where they put the tool changer on the front, and it's much better to put the tool on the back because at the back you've got more space on the lathe than you've got on the front. So you're limited to what diameter you can cut if you have a tool changer on the front.
The thing is in the way to change the material. So if it's at the back, that's why you get close to the...
Yeah, but I'm talking about commercial machines, you know. Rocco bought a machine and he's so sorry he's now actually going to replace the tool changer because he hasn't got enough radius to do a decent size on a big lathe. The tool changer limits the size of, and not the bed, but the tool changer limits the size of what you can cut on the lathe. And they've got a lot of space at the back. If they put it at the back, then they could have solved the problem. So these guys, standard machine, they've got a tool changer at the back. So they've got an X positive and an X negative, depending on what machine you've got. Then they just explain facing and all those kind of things. I just wanted to show you, and I'll give you an impression of the manual. It's quite a detailed manual. Chamfers, it's all explained. Tool orientation, and so on. There's the thread cutting, internal thread cutting, external thread cutting. It's well explained. So I think that's basically this conversational programming is the big difference, or the big step up, I would say, from SA-CNC, between SA-CNC standard, the older stuff, and Pathpilot. There is a new development now in SA-CNC where they've changed over from the old Gcode programming and Glade and VCP, all kinds of stuff. They're changing over to Qt. Qt is now the new GUI language, and in fact the stuff is coming almost every month, something new coming up now. So if you want to follow that, search for Qt, SA-CNC Qt VCP. You'll find all the latest stuff that they're developing. Unfortunately, you get guys that they're quick to draw a nice GUI, but they're not quick to link it in and make it workable that you can use it.
You can, if you run it just a demo machine, you can run that, the whole profile thing, and then just take the Gcode and copy it into another machine. That's conversational.
Yeah, you can. You store you store the Gcode. When you store the file, you don't store the data that you put in. You actually store the Gcode. So you can take that Gcode and run it on another. Yeah, you're right. You can do that. Yeah. And you can set it up. There's simulations. I don't know whether I've got anything here, but you can simulate it without a machine. You can run it completely. It will generate the Gcode and store it in a file. That's a good idea.
Machine is.
Okay, so that's the manual that I wanted to show. It goes into the detail of your tips and so on, the geometry, radius compensation.
Yeah, that radius compensation when you want to chamfer there, we can.
All of that.
Or it tells you the radius is wrong.
Yeah.
The leading.
Well, it's quite complete. So it's a good manual. They've worked a lot on the manual. You can see every time when you get a new version that they've improved the manual. That's all the Gcodes.
They don't have non-standard Gcodes. It's all the Gcode standard Gcodes.
They're standard Gcodes, but they've added. What they've added is also basically standard. I'm just looking for the extras, but I don't see it here. Model groups. I don't see the G71 somehow. I don't find it, but this is G76.
With this custom Gcode, or do they just write out all the Gcodes for that? Right?
It's a standard, but it's a. Let's see if we can find a definition of it. These are the standard ones. See if we can find a definition of what they've added. These are standard SA-CNC codes. 40, 41, 41, 53, 54, 60, 64. Here's the standard threading one, 76. I think that hasn't changed. It's got the same definition. I think it's in SA-CNC. Tapping, G84. That's interesting. They haven't actually defined the value. I must just check it. The new code for profiles.
That tapping cycle G84, is that standard? I can't remember how it did.
6536.
I'll have to check. I haven't actually read the manual that deeply. They don't seem to document that G71 command here. Maybe it's somewhere.
Because you can only use it through the GUI.
Yeah, it's not standard, in the sense that it's sort of unique to Pathpilot, maybe. But at least they should document the parameters. You can see it, they can't hide it, but they don't seem to put it in the document. I will check on that and see if I can find it. Yeah. Okay, anything else on this? I think that's basically what I wanted to say about Pathpilot. Pathpilot does not use the same card. They use a 5i25 or they use a 7i92 with their own breakout board. This card has got everything on it. You don't need anything else. It's a complete breakout board, stepper driver, everything included in the one card, plus the connection to the computer. Whereas they split it into two cards. A small little card that goes in the computer or outside, but it's a small little card, and then an extra breakout board.
But to just confirm, if you've got a new brand machine, when you buy it or get hold of this system, It's got the operating system as well, the whole thing. You don't, or you have to put your own Linux in.
Now, Pathpilot comes with an operating system.
So
If you buy that $10 stick, a little USB stick,
so it's just 1 unit, and that's
it's
it.
1 unit, yeah.
You can buy a new machine and boot it up on Pro.
Yeah. When we use Linux CNC, we also, you can download a complete system which includes Linux CNC, or you can just load any Linux and then, not any, but a Linux system, and then load the Linux CNC into it. With a bit of skills you can do it. It's easier just to download the ISO on the disk.
So ISO for the Mesa, the 76, not the object.
Pardon?
The ISO for that card is not available yet.
The ISO for the card.
Yeah, on the CD, the whole thing. Or
The card is not, it doesn't, you get Linux is independent of the card.
No, I know, but remember the procedure that you explained to us, that you have to download Stretch and go through all that.
No, there is now ISOs available.
Is it?
Yeah, there are ISOs available. I must spend maybe next time a little bit on that to bring you up to date. There are ISOs available. It's still called test or something, but you can download an ISO. That makes it easy. You don't have to build it up like I did last time.
What's the name, Prof?
Pardon?
You don't know offhand what's the name of that?
No, but I can give it to Ruben and he can put it on the. There's definitely now improvement on that you can download ISOs. So. Makes it easier. The Pathpilot is not a ISO. It's a clones the disk. It actually overrides the whole disk. It's not an installation as such. It uses CloneZilla or one of these clone programs. I'm not sure which one. So we're going to be busy with this and trying to get at least those 2 Tomex down in Hermanus to upgrade to Pathpilot from the older Tomek situations.
Ek het prof al daai masjiene gesien.
Yeah. Okay. Okay, that's it then for the first part. It's wat jou projek en Ruben kom op vra 'n bietjie van sy projek vir ons te vertel.
Dis jy as jy op ek het nie veel gesien maar. Ons is 'n paar nuwe mense, so miskien moet ek net gou weer vertel. So ons het 'n mini-mill projek, né? Of 'n Meso-mill noem ons dit. Prof Rudi sal nou miskien 'n bietjie wag nou eers daar.
Ek kyk net waar moet ek begin?
Nee, ek weet nie waar om te begin nie. Dis net daar so, dis reg.
Ek soek ek begin.
So daar's nie 'n begin nie. So die Meso-mill gaan uiteindelik 'n klamp nodig hê wat jy jou werkstuk mee vasklamp. En Prof Rudi het 'n Deckel klamp waarvan hy eintlik 3 gekoop het, klompie jare terug. En dit is 'n baie unieke Duitse ontwerp, 'n hoë kwaliteit ontwerp wat die glybaan van die klamp basies 'n veervormige, ja, miskien kan ons.
Dis nou die negatief, né?
Ja, gaan nou die positief. Ja,
dis die regte gietstuk hier.
Ja, hier is die regte gietstuk uit so veervorm en dan gly die knypgedeelte hierbo. Of hy het 'n blok aan die een kant wat hom vashou en die knypgedeelte gly van die ander kant af. So, dit is omtrent so 'n 300 mm ding uit gietijster en ons 3 komponente wat gegiet moet word. So, wat ek nou hier gedoen het, is ek kan dit nie vanaand saamgebring het nie. Want ek het die gietijster geneem en dit opgebou met skuinplastiek. Dit was nogal 'n storie om dit reg te kry, want aanvanklik het ek karton gebruik, maar omdat ek 'n dubbel plakstrokie gebruik, die cello-type so double-sided type, nee. Maak die metal eers mooi skoon, plak die kleefband op, plak die karton op en dan begin jy met 'n mes, 'n baie skerp lemmetjie sny. Dan tel hy daai plakmiddel op en dit raak so gemors, jy kan nie werk met dit nie. So toe trek ek al die goeders af en dis het ek 'n dikkerige 3,5 mm skuinplastiek bord wat redelik ferm is. Toe plak ek dit bo en met die skerp mes sny dit baie maklik. Maar nou sit jy met rande wat nie heeltemal reg is vir silikoon gietstuk nie. By the way, hierso. Kom maar hier nog kyk. So daai ding word dan voorberei en dit word dan in 'n silikoon pot gegooi basies. So lyk.
Is dit silikoon daai?
Daai is die silikoon, ja. So om te keer dat die afwerking van 'n swak standaard is, het ek toe hier is die tipe band wat hulle gebruik by motorkarverfplekke. Hy plak ferm, maar hy bring nie hy plak nie so erg dat hy enigiets agterlaat of van die verf gaan beskadig. So dit het maar alles mooi bedek met dit. Sodat jou gietgedeelte waar die masjineering gaan plaasvind, dan was die 3,5 mm dikker is. So hierdie gedeelte en aan die binnekant. En dan as ook aan die onderkant.
So daar is nou karton, of wat is onder dit?
Onder hierdie is dan nou die skuinplastiek.
Skuinplastiek.
Ja, dis 'n baie ferm, digte skuinplastiek met papier aan die buitekant. So hierso en daar, en aan die onderkant kan jy dit sien ook daar. So dit ek hierdie hele ding so gepak, en dit is eintlik 'n paar uur se werk. Dit lyk nie so nie, maar om het relatief netjies te kry, is dit nodig geweest. Die tweede ding wat ek toe agterkom is, hoe om hierdie ding binne in jou, jy wil dit nou in 'n boks sit, miskien met prof prentjie gaan nog, ja. So hierdie ding word dan basies in 'n houtboks gesit om al hierdie goed by mekaar te hou. En gaan gou die prentjie terug. Ja, sien, dit ek van die onderkant hout pennetjies ingesit, sodat hy basies in die boks gaan lê. En dan, wanneer jy die silikoon ingooi, dan loop dit onderin en loop boven. Die tweede ding wat ek te agterkom is, jou swak afwerking wil jy aan die onderkant hê, want die silikoon moet boven loop. Hy is geneig om borreltjies te laat opgaan na die bokant toe, soos wat hy half
Moet mens om nie vibreer of iets?
Ja, mens moet hom opvibreer of jy met 'n
met 'n vacuüm
met 'n vacuüm ding en so wat ek nie het.
Die wyte albei.
Ja,
kan vibreer en dan eers vibreer dan sit hom net.
Ja.
Maar wat is silikoon wat jy gebruik?
Ek het IMT sure.
So hulle
still cost 25 of so.
Ja, want hulle ken wat as jy laat staan, dan kom sy borrels ook uit.
Ja. Hierdie een werk, maar die probleem is, omdat ek alles in een gegiet het, kom die borrels aan die onderkant.
Ja, maar so gemeng in die neers laat staan, dat sy borrels uitkom.
O ja.
Dan giet jy op.
Ja, ek het seker sê 10 minute gewag en toe wat te min was.
Groot is like box.
Box is omtrent so.
Ons het 'n vacuum chamber, maar is dink ek groot genoeg vir hom.
Is dit?
Ja.
Meen jy by die huis?
Wel, elf met my betaald my
Is dit?
gegiet het daar.
Jy het al hierdie goeders gedoen hoor.
Maar is dat klaar gegiet?
Ja, is
Ek wil net gevra het, so jy styrofoam, jy het nou compressed styrofoam dan gebruik.
Wat is nie, so ek makliker wees om maar klei van dit te gebruik wat hulle gebruik as hulle ding opbou nie.
Hoe sou mense daai klei plat kry, netjies kry?
Jy sien die mense nou 'n bietjie gaatjies en so.
Ja, dit is juist aan die onderkant wat hy die gaatjies gelos het. Wat nie vir my 'n probleem is nie, want dit gaan in die positief van die gietstuk kom, wat die mens net gaan afmachineer op die einde.
En die bokant lyk nie sleg nie.
Ja, baie mooi. Die bokant se definisie is baie mooi.
Ja, ek sien al die gleufels was mooi.
Ja. So, die proses is 2 dae, wanneer jy die goed gegiet het met het 24, sê 2 dae staan. En dit het ek gedoen, toe ek het nou opmaak, as ek so opgewond, ek wil het nou dadelijk giet, toe gooi ek die volgende stap in, wat silicon carbide is.
Excuse toch, het jy hierdie geskui, het jy daai van hierdie geskui?
Ek het dit met 'n mes ook.
Hierdie is 'n snitvlak.
Ja. Gaan nou 'n bietjie aan, dat is net by die snitvlak regkom. Nog 'n bietjie, nog een. So hierso is basies, was ek bezig met die snit, ja.
Ja.
So sny baie maklik, jy moet hom net 'n bietjie trek en dan met 'n skerp mes dan skeer uit. So, ek is tevrede met daai, ek stem saam dat 'n mens moet vibreer en die vakuum toepassing sal dit mooier uitkom. Vir my doeleinde is as ek slim, want op die dele wat gaan afgemachineer word, gaan die lelike goeders wees. En waar ons die definisie nodig het, verwag ek dat dit mooi gaan wees.
Jy kan hom ook sien bietjie vinniger wil dat set om die oond en laat temperatuur.
Is dit, my vrou gaan baie daarvan hou.
Kan jy dit sê dan?
Moet ek bietjie koekleersel en geersel en ryker maak?
Nee, jy moet net wat sê nie daar is. Sure, maar is 'n klomp.
Ja, goed, so die een ding wat ek agtergekom het, hierdie is nie 'n goedkoop proses nie. Want jy kyk so na vir die silikoon so R1000 vir 5 kg. En ek het al 5 kg, nee, ek het 4 kg opgebruik op hierdie. So as jy kyk so na R800 vir daai boks. En dan, wat nog duurder is dan hierdie goeders, ek het sommer, hulle kan hier binnenkrap, dit is 'n A en 'n B wat jy saam sit. En wat hierdie is 'n silicon carbide, baie fyn silicon carbide, wat hulle gemeng het met epoxy. En so 'n potjie is R300. En 3 van hulle het daarin gegaan. So dis ook R1000, dis R2000.
En dan word hy hard, soos
hy word 'n 9, is net so 'n bietjie onder 'n hy sê is net so 'n bietjie onder 'n diamant.
Ek wil net met silicon carbide.
Dit is maar wat hulle doen, dit is wat hulle gebruik vir offisieel vir gietstukke.
Ja, hulle honderde materiaal.
Ja.
Jy kan vir hulle, ek meen daar's engineering materiaal, jy kan vir hulle sê jy moet soveel rok wil hê, jy moet so bypoor wees, so plekbaar, so hulle duisende van die goed wat jy kan kry op internet.
Dis nou wat hulle sou voorstel, jy kan maar omstuur en kyk, hier en daar 'n bietjie taai aan. So vat na die taai met.
Is daar 'n plaatjie daarvan al?
Ja, dan nog A en B wat jy bygooi en dit is verskriklik dun. Hy loop baie mooi in, alles in. En die definisie, draai daai ding om, dan sal jy die krappe binne in die bakkie sien. Sy definisie is ongelooflik hoog. As jy hom so in die lug, kry. Letterlik al die krappies en so, het hy oorgekom. So, die goed is 4 dae. Ek kan sorry. Ek kan Saterdagmiddag nou eers dit uithaal, want dit is dan 4 dae terug gedoen. Maar toe, of Rudi wou dit graag van ons sien, maar toe ek het besig is te besluit ek nie, nou wil ek dit in. So, volgende maand sal ek bietjie saam.
Kijk, so daai is 'n redelike harde pattern.
Hy is redelik hard. Ja. Wat die ouens gedoen het, omdat dit so duur is, ek het gesien hulle het 'n groot vorm gemaak, en hulle eers hout half, vierkantige hout gevat, om hom op te vul en dan nie goed rondom gegooi. Dan is dit so half 'n eenheid.
Dan vul hy weer.
Dan vul hy meer, ja. So goed, daar's miskien as ons weer 'n bietjie aangaan. So
So daar is nou net waar ek besig was om het op te vul.
Dis in die epoxy hierdie dan.
Daar is die epoxy, ja. Mens kan sien nie, kom die borreltjies ook nou na boom toe.
Ja.
Het jy dit in een dag gegooi of het jy verskillende...
Ek het in een gou, ja.
En dit het baie warm geword.
Ja. Jy kan sien hierso het ek basies...
Dis ook om my 4 dae vat om te cure.
Ja, ek het hierdie toegemaak en die laaste laag deur die gate gegooi. Sodat die gate is so half bietjie van 'n reservoir hy.
Yes.
Ja, en toe om alles mooi stabiel by mekaar te hou. Dit is in die kombuis by the way. Maar dis nie binne die wind nie.
So vry is dat ongeluk.
Ja, nog so een ander proef. En dan het ek maar net met waspapier toe en dit mooi toegeskryf. En dan sal ons Saterdagmiddag sal ek na proef toe kom en dan miskien wys dit.
Kom met jy net om bo gelyk te kry.
Ja, hy druk so 'n bietjie in.
Druk 'n bietjie in.
Ja. Ja, nog miskien.
En hy krimp nie, dis hy veronderstel.
Ek dink hy het 'n klein persentasie.
Is dit?
Ja, ons sal maar sien waar daar uitkom.
Dis baie sal as we 1 mm kleiner as die dekkel is.
Ja, dit is nie 'n probleem nie. Hy's okay.
So die wat's next na hierdie?
Ja, so daar's nou jy 'n bietjie van 'n skaal nodig en ek moes van goeders koop om te meng en alles. En ek het so gekyk na die kombuis te jaag my vrou my uit. En ja, volgende stap. So daar is nou net weer die vorm. Dis die onderkant, nee? Die voetjies wat jy daar kan sien. Sien daai voetjies is swart, die skynplastiek. En daai het ons gesien, dit is nogal netjies. Ek moet sê, ek is tevrede met daai aanwerking. As 'n mens hom voel, is hy ook lekker glad en so.
Ja, dis hier is vlakke wat jy nie gaan machineer nie.
Nee, jy gaan dit nie doen.
Dis net hier wat gemachineer word en
Ja.
heel bo word gemachineer word. Hier word nie gemachineer nie.
Ja, en jy sal miskien die gate hierso, miskien net vlak. I mean, op elke een.
Ja.
Ja. As hy nie klank lyk, maar nog meer wees as hy was voor die tyd.
Ek hoop so.
Ek het probeer mooi dat.
Hy is nie vervangbaar daai ding.
Nee. Goed, so wat volgende is, ek sal hierdie, kyk nou hoe dit uitgekom het, dan sal ek dit, ek wil nie te ver ry eers, ons sal later daai spesiale gieteister. Wat is die naam? Meso-mill, hoor? Meso-mill, ja. Ons sal later, ek gaan maar eers daai sit doen in Silverton en vir hulle sê, doen gou vir my een, laat ons net kyk hoe dit lyk. En dan sal ek aangaan en die ander stukkies giet, so dan ons gietstuk. En dan moet ons, maar ek wil dit graag op my masjien afwerk, in my garage wat 'n vreesmasjien is, en kyk wat so kwaliteit ons kan kry. En dan sal ons kyk na hoër volumes. Vir wie van julle wil hê of nodig het, dan kan ek 'n paar laat gee.
Ja, ons plan is eintlik om een kleiner te maak nog, want ons het nou die kerkmodel van Fusion geteken.
Ja.
En om 1,75% te maak en 125% te maak. So dat ons
Hoe lang is daai vice aan julle ons?
De 300 mm.
Ja, hy sê 110 wyte met 'n opening van omtrent 100. Ja, so dan wil ek een maak wat 75 is en die ander een wat 120 is, 125 is omtrent so.
Wat se masjien moet jy CSP-V grooves daai dan?
Ja, hierdie vlak, daai vlak moet baie akkuraat wees en jy het weerskante, is 'n veer en dan die bokant, daai onderste vlak wat nou eintlik bo is, hy's nou onderste bo daar. Kom ons kyk na die ander foto hierso.
Hy is 'n toegeplak.
Hy het 3 vlakke wat nogal moeilik gaan wees om te kry dat dit goed pas. So, die Duitsers het nou 'n manier om dit gekry om dit te doen. Maar hierdie vlak en daai vlak, daai 2 vlakke, dis waar die ander ding wat hy nou nog nie gewys het nie, wat daar ingly, die boonste gedeelte wat die klou vat, hy gly daar in, en dan kom daar die ding bo op, so daai ding moet, 3 vlakke moet presies reg wees, vir daai ding om geen speling te hê, of baie min speling te hê.
Ja, hulle die middelste deel wat hierin gly, met hulle gelyk geskraap, met die bokant. Maar ons het gedink om dit, wanneer jy nou die veer reg het, en hy basies vastgesit is, dan die hele ding basies net te vrees oor of te slyf. Laat hy gelijk is, en dit van mense was straat.
Dit gaan maar 'n bietjie trial and error wees.
Ja.
Dit gaan maar 'n bietjie probeer en kry wees.
Ja, ek dink ook so, ja.
Baie beweging gaan nie op hom hê om hom te gebruik.
So 100 mm, 120 mm.
Maar dit is wel stadig, dis moet net met 'n
Ja, dis met 'n ja,
so
dis
dis
met 'n
nie nodig om te skraap.
skroefdraad, ja. So ek weet, daar's al iemand wat saam is wat wil ook 'n klant hê. So is daar nog mense wat sou belangstel. Ja. Ja. Net stukke en so, ja.
Wat se materiaal is daai een? Is dit net skoon straightforward cast iron? Is nie
Dit lyk so, maar ek weet nie. Ek weet nie. Dis goeie giethuisstuk.
Ja.
Dekkel-type-vice is goeie.
Maar is nie surface hardened of iets op hom?
Nee, glo.
Ja.
Ek het myne al jare en hulle het geen slytasie op nie. Kan maar kyk.
Kyk, ja, dekkels. Die goeie ding van hierdie ontwerp is, hierdie bek as hy nou oopskop basies. Hy druk hom terug in die houer self. Dis nie dat daar probleme is wat die ding trek of uitklim nie.
Die ander groot voordeel is die skroef is heeltemal toe. Daar kan geen snysels by die skroef uitkom nie. En derdens, jy het heeltemal 'n plat vlak waarin jy vasknyp, jy weet, die volle wyte van jou kloue waar jy jou ding kan opneersit, so jy hoef nie te bekommerd te wees dat jy te min.
Ja, want hierdie ding vul hier in, die skraap.
Van kant tot kant is een vlak. Van buitekant tot buitekant is een vlak.
Erik, hoe het jy gedink om daai wies te sny?
Ek het gedink, ek het 'n tilting tafel op my presmasjien, so jy doen 'n opstelling en jy sny die ding met dieselfde
Strykkant.
opstel, ja, strykkant.
Met die kant van die buite.
Met die kant van die buite. Maar wat my pla is,
draai.
wat hulle hier gedoen het, is hulle het gesly. Hulle het basies groefies ingesly, of 'n tekstuur ingesly. So, want hier is gaatjies vir olie, wat hier deurkom en kan dit inkom. So, daai tekstuur wat hulle opgesit het, hou soort van die olie. En as die mense dit nou gaan vrees, dan gaan hy half mense dit nie hê nie. So, slyp sal seker maar die beste wees. Maar dit sal maar nou eers met die presmasjien los. Wat ek gedink het, miskien 'n oulike idee kan wees, is om die twee parte op mekaar in te slyp. Met die hand. Ek weet nie of dit moontlik is nie, enige idees. Soort van, as jy 'n skuurpooier insit, en die goed op mekaar insluit.
Theorie moet jy eintlik 3 goed hê.
Jy moet 3 goed, ja. Maar mens kan hom omdraai. Of 'n mens kan net meer van hulle vat en hulle uitdraai.
Ja, dit kan jy.
Ja. Ek weet nie hoe lang proses dit is en hoe goed dit gaan uit.
Jy kan weet dit ja, man pasta is die eerste. Dat is slyp.
Nou wat ek gesien het in Switserland is hulle sal daai goed op 'n groot slypmasjien sit, soms so 10 op 'n ry. En dan die steen, die diamantsteen wat hulle weer slyp kom teen die hoek in. So die goed word net plat op 'n tafel gesit, hulle word opgelyn en dan sny hulle soms so 10 op 'n slag van die een kant na die ander kant toe. Met 'n 4 meter bed slypmasjien, soos wat Deckel ook het, so 'n tipe masjien.
Sal sy masjien dit kan doen?
Ja. Jy kan die kop stel teen die hoek.
Ja.
Slyp hulle almal. Jy slyp sommer die ander sodat hulle ook op 'n slyp teen dieselfde hoek slyp die ander wat binne inpas.
Ja.
Alles met een slag.
Alles wat een slag. Hoe sal so 'n opstelling wees? Hoe doen 'n mens daai opstelling op die...
Nee, jy sit die goed net plat neer op die tafel en dan kom jy met jou steen kan jy mos na die hoek stel.
Ja.
En jou slypsteen kan jy die hoek stel.
Ja.
Dan gaan hy maar net bo-oor.
Sal 'n mens so iets wil ondersoek? Dink dis 'n klink na 'n goeie plan.
En die steen gee ook vir jou daai ruffeltjies wat jy nodig het vir jou olie.
Is dit omdat die
sny met die kant, jy weet jy loop die sny met die kant van die steen en hy maak daai groepies soos hy sê.
Ja.
Dan of hoe stadig en hoe vinnig jy hom beweeg. Ek is nou nie 'n slyp-ekspert nie, maar dis wat ek nou.
Ja, en as 'n mens dan die binne en die buitekant klaar geslyp het, dan moet jy eintlik
die goed in mekaar sit en dan moet jy die buitekant plaasdraai.
Dis
Ja, die mens.
Dis maar eintlik dieselfde probleem as 'n draaibank. Jy weet 'n draaibank wat nou hierdie twee hellings voor het en dan hy agter ook nog een om daai opgestel te kry goed doen maar op so tipe sluitmasjien. Dis akkurate opstelling en meetwerk wat jy moet doen. Dis maar dieselfde dan.
Okay, so daar was vordering. Dit is die vordering.
Ja, ons
Goeie werk.
Ons wag in spanning tot ons die eerste een sien.
Jy laat iets stuk sien. Sien is beweging.
Robert, wil jy gou iets sê oor jou storie?
Nee, ek het nie regtig veel te sê nie. Is nie 'n nuwe kas wat ek vir my
Vertel wat dit is, ja.
opgestel het met, ek het 'n ou breakout board nog van Greg vir my parallel board.
Kan jy 'n bietjie optel dat ons
So het ek nou hierdie gemaak. Met sy power supply en goeders en dan die Mesa kaart is daar so en dan hier is maar net alles power supplies, hier's 'n amp meter en dan gaan ek my Gcode hier fit en accessories daar so. En dan alles met plugs aan die agterkant uitkom.
So dis is 76 daar.
Yes.
Ja.
Ek het hom al actually 3 jaar. Ja.
Wat 'n ampmeter is dit?
Ek is ene wat ek sommer by micro-robotics koop. Hy wys net voltage en amps.
Vir waarvoor?
Nee, ek het net nog gedink dis interessant.
Maar lees jy dit terug na die rekenaar?
Nee, hy het 'n skermpie aan die voorkant. So as die masjien hardloop, kan jy net sien
hoeveel hy trek.
Ja. So ek het dan nou plugs agterin gesit. So al die ander 220 volt word ook hier ingeplug. En dis maar dit.
Wat se plaas nie gebruik fuse stopper motors
Nee, hy praat om van die drywer af na die stepper te gaan. Daar is dan metaal plugs wat micro-robotics so verkoop, maar ek is nie so lekker happy met die kwaliteit.
Dis spesifiek ook vra ek het hulle so gekyk.
Ek het sulke ander gekoop, maar dit is plastic en dit is actually IP rated by Communica 'n lang terug. Maar die probleem is die kabels wat hang is actually swaar en dan breek hy die plug.
Jy weet mos hierdie microphone plug, jy kry 'n 4-pin en 'n 6-pin.
Dis baie soos die wat
jy kry 'n groter een wat 20 mil diameter is. Jy weet, so hy is nou gemaak vir tot 40. Jy kry verskillende ranges tot die grootes wat 100,000 rand een kos, maar ek het vir my sommer 20 van daai groter is ingevoer uit China.
Okay.
So dan het hy nou dikker dra en hy kry ek dink
jy word nou vir avionics plan.
Ja, dis daar, ek dink hulle noem dit
Ja, jy weet ek nie, so dit is avionics plan.
Ja, hy skroef op vas.
Ek dink die wat skroef nie vas nie, as ek dit nie
Ja, dis is hierdie hy skroef so 'n bietjie vas. Jy weet,
Hulle kan ook net 4 invloed, nee.
ja, hulle is die groot ends. As jy groter is, kry jy wat meer ends van. Want jy is hierdie ander square ABD plugs en goed kos 'n karse prys een.
Want daar gaan dit gold-plated pennetjies en
Ja, maar nie dink dit help nie, dit is daai ABD breker vir 10 keer 'n switch dan is ook niks.
Goed baie ding.
Ja, wat jy 3 dae lank soek.
En that's it. Bro.
Daar lyk maar goed.
Dankie.
Okay, baie dankie. Ek dink dis dan nou ons maak 'n breek nou en dan na die breek gaan ek so 'n bietjie net wys oor die Meso-mill was 'n spannend and we're going to do a finite element money mold just to show you how it performs in terms of stiffness and movements and so on.